Today, we are going to unravel a story that connects two worlds you'd probably never think to put together: luxury silk fabrics and, well, the very first lines of computer code. Believe it or not, there is a direct thread that runs from the clatter of a 19th century loom all the way to the laptop you might be watching this on right now. So let's pull on that thread and see how a simple piece of cardboard basically became the great-great-grandfather of modern software.
Okay, get this. This quote comes from the early 1800s, and when you first read it, it just sounds wrong. Impossible, even. Software piracy? That's our problem, right? We think of hackers copying files, breaking DRM, not people stealing stacks of cardboard from a textile factory.
And that right there, that is the big question for this whole explainer. To answer it, we've got to jump back in time, to a world where programming wasn't about ones and zeros, but about, you guessed it, threads and patterns. So first things first, let's talk about the problem that needed solving. Before automation, if you wanted to create fabric with really complex, beautiful patterns, like brocades or damasks, it was one of the most difficult, slow, and genuinely dangerous jobs in the world.
I mean, just look at the human cost of this. Can you imagine producing just a couple of inches of fabric in an entire day's work? The process needed a master weaver running the loom and a young assistant called a drawboy who had to sit perched on top of this massive machine. The drawboy's job was to manually lift and lower specific sets of threads for every single pass of the shuttle, and these threads were attached to heavy reeds. We're talking about kids lifting more than half their own body weight over and over and over. It was just brutal, exhausting work, and of course incredibly easy to make a mistake.
So this incredibly inefficient and dangerous system was the exact problem a man named Joseph Marie Jacquard wanted to solve. He was the son of a master weaver, and he'd actually worked as a drawboy himself, so he knew this pain firsthand. And his solution, well, it was going to change everything.
In 1804, he showed the world his masterpiece, the Jacquard machine. It was this complex-looking device that sat right on top of a normal loom, but its real genius was in something remarkably simple: a long chain of pasteboard cards with holes punched in them. This, right here, was the key to automating art.
So how in the world did it work? It's just a brilliant piece of mechanical logic. Each card in the chain represents one single row of the pattern. The machine presses that card against a set of needles. You could think of it like the machine is asking a simple question: is there a hole here or not? If there is a hole, a needle pokes through, which engages a hook, which lifts a specific thread. If there's no hole, the needle gets blocked, and that thread stays down. It is a perfect binary system. Hole means on, no hole means off. It's one simple command, repeated thousands of times to create a masterpiece.
So here it is, the crucial point of this whole story. That sequence of cards, that was a set of instructions. It was a program. And the loom? The loom was the hardware that executed those instructions. If you wanted to weave a completely different pattern, you didn't have to rebuild the machine. You just swapped out the deck of cards. This was, for all intents and purposes, the world's first programmable device.
And this is the moment where the idea breaks free of the textile mill. The concept of using punched cards to store and execute a sequence of instructions was just too powerful of an idea to stay stuck making fabric.
This quote just perfectly captures the conceptual leap that's about to happen. It's from Ada Lovelace, who many people consider the world's first computer programmer. She was writing about Charles Babbage's proposed analytical engine, basically a design for a mechanical, general-purpose computer from way back in the 1830s. Lovelace immediately saw that the exact same principle used to weave flowers into silk could be used to weave numbers and symbols to perform complex calculations. I mean, just look at this direct parallel. In the Jacquard loom, the card controls physical threads. A hole is a simple binary command: lift this thread up. The output is a physical thing, a beautiful piece of fabric. Now, in Babbage's analytical engine, the card would control abstract calculations. A hole would represent a number or a mathematical operation, like add or subtract, and the output would be a mathematical result. It's the exact same logic, just applied to a totally different universe of problems. Now, while Babbage's amazing engine was never actually finished, the punched card's next big moment wasn't in complex math, but in simple counting, but counting on an absolutely massive scale.
The journey just keeps going. After Jacquard's machine and Babbage's theory, the idea was finally made real by a guy named Herman Hollerith. See, he was facing a monumental task: the 1890 U.S. Census. The census before that one took nearly 8 years to count by hand, and the government was terrified the 1891 would take even longer. Hollerith's solution was to adapt the Jacquard card.
And this is the key shift. Instead of a hole meaning lift a thread, a hole in a specific spot on a Hollerith's card now represented a piece of data. So for example, a punch in one column might mean male, a punch in another could mean farmer, and in another, age 30 to 35. Every single person's census data was encoded onto one of these cards.
And then Hollerith built these incredible electromechanical machines to read them. When a little pin passed through a hole, it completed an electrical circuit, which then clicked a counter up by 1 on a dial. These machines could sort and count data at a speed that was just unimaginable before. Because of this, the 1890 census was done in a tiny fraction of the time it would have taken. This was, quite literally, the birth of automated data processing. Now, Hollerith's company, the tabulating machine company, would eventually merge with a few others and become a little startup you might have heard of, IBM. And for the next 70 years, his punch card system would become the language of computers.
I mean, think about that. From the early 1900s all the way through the 1970s, if you wanted to communicate with a computer, you used a punched card. Entire programs, huge data sets, every line of code, it was all stored on these stacks of stiff paper. There were entire rooms full of people called key punch operators whose whole job was just translating human information into holes.
And the tools they used evolved, of course. It started with manual punches, but pretty soon you had these electromechanical machines like the famous IBM O26, which kind of looked like a metal desk with a typewriter smashed into it. You'd type a character, and the machine would clunk, clunk, clunk the right code of holes into the card column, and it would usually print the character at the top so you could actually read it. And here's the funny part. They even used a special punched card called a program card to control the key punch machine itself for stuff like tabbing. So it was essentially a program used to help you write another program. You know what technology has really made an impact? When the machine's name becomes a verb. To key punch just meant to do data entry. Even long after the cards were replaced by magnetic tape and computer terminals, people would still talk about key punching in the data. Its legacy is literally baked right into our language.
Which brings us all the way back to the beginning. That stolen deck of cards from the 1800s? It was software piracy. Because that deck of cards was the program, the set of instructions that gave a simple loom its unique and very valuable ability. A physical set of instructions, born from the need to make beautiful patterns in fabric, laid the foundation for everything we do with computers today. The very first software? It really was woeful. It really makes you wonder, doesn't it? The Jacquard card was a simple, elegant solution to a very physical problem, but it held this seed of a massive, abstract idea inside it. So what's today's equivalent? What simple, maybe even overlooked idea in our world right now might just be the punched card for a technology that we can't even begin to imagine yet?